All right, so we have finished up the theory for our update position method, and really it's just time to get this all worked in, and I think we'll be pretty much done.
Right, so let's get started.
Go for it.
First thing to do is add some more public floats. This one will be X smooth. And let's set that to a default value of 0.05f. Second one will be a public float called Y smooth. We'll set that's default value to 0.1f.
That's not 0.1.
It's close enough.
Okay.
It's half a zero.
All right. It's the back half, really.
I wonder what half a zero is.
0, according to my math class. But anyway, go ahead.
I failed math. It's like going, what do you think I have such a hard time with this? All right, we need some velocities.
So when you divide by 0, you get the problems.
You
need a velocity. That's right.
Yep.
For X, Y, and Z.
So we're going to make a private float. This will be VLX, and we'll set it to 0. Let's speed this up by duplicating it. We'll need 2 more. We need one for Y. We need one for Z. And we need to save another vector. This one will be a private vector 3. And we'll call this one position. And why not just set it to 0, just to be thorough.
Okay.
So that should be the rest of the fields that we need. So let's drop down to update position and let's start calculating it out. We had mentioned that we need to break this up into 3 different steps so we can smooth out X, Y, and Z separately. Right. So we'll start with assigning a var position X equal to, we're going to rely on the mathf smooth damp method again. Requires 4 pieces of information. It's going to require position.x as our start. We're going to use desired position.x as our goal. We're going to use a reference to velocity x as our reference for keeping track of velocity. And we're going to use x smooth for our smooth time. The same line is used 2 more times, just like before. We need to do a Y, a Z, and instead of using position X for everything, we'll use Y and Z respectively. Now, same with velocity. So,
and then with X smooth as well.
But the only one we need to change is Y.
Right.
Because Z will use the same value that we have for X smooth.
Right.
This will smooth each one of the positions components individually. Now we need to take the result
and assemble
it back into a positional vector. So we'll take position equals a new vector 3. We'll pass in position X, comma position Y, comma position Z. That puts our vector back together. Now we have a position to work with. All we have to do there is take our transform, take our position, which is the camera's position, its real position in the world, and set it to equal the position that we just calculated. And finally, we take our transform and we tell it to look at our target lookup. That's it.
That's it.
We build it, make sure there's no errors, We should have a working camera.
Well, let's hold off on the testing until the next video.
All right.
So that's going to wrap things up here for the implementation process. So thanks a lot.